Hello everyone. The chapter which we are going to start today is chemical reactions and equations. Let us start with the introduction part of this lesson. In the beginning, a few situations from our daily life are given. So let us take a look at it one by one. The first situation is milk is left at room temperature during summer. Okay, we all know that when milk is left at room temperature, and that too especially during summer, then the milk gets spoiled, so it becomes sour. This is because a few oxidation reactions takes place in that milk, and also microbes develop in it, and therefore it becomes of no use. That is why we keep the milk in the refrigerator during summer. Okay, the next situation is iron objects are left exposed to humid atmosphere. We might have observed that when iron objects are left exposed to humid atmosphere, then a reddish brown coating appears on it, and this reddish brown coating is what we call the rust. Okay, this happens because of the humid atmosphere. In humid atmosphere, water vapor is present and also oxygen is present. Okay, when iron reacts with water vapor and oxygen present in the atmosphere, then iron oxide is formed, and this iron oxide is rust. Okay, we will look at the process of rusting in detail in the upcoming lectures. Third situation, grapes get fermented. We know that wine is extracted from the fruit juice, and that is grape juice. Okay, when yeast is added to the fruit juice, then yeast converts the sugar which is present in the fruit juice into ethanol, and carbon dioxide is also released in this process. Okay, in this way wine is prepared from the grape juice. The fourth situation, food is cooked. Okay, cooking breaks down some of the fibers present in the food, and it also breaks the plant cell wall, and in this way it helps in the process of digestion. Okay, it would be easier for the body to digest the food that we consume. Okay, the fifth situation is food gets digested in our body. We know that digestion is the process in which the complex food substances in our food gets broken down into simple and absorbable forms. Okay, here the complex food substances are broken down into simpler forms. Okay, for example, the carbohydrates which we consume ultimately gets broken down into glucose. Okay, and fats into fatty acids and glycerol, proteins into amino acids. The sixth situation is when we respire. We have to note that breathing is quite different from the process of respiration. Breathing is where we inhale oxygen and exhale carbon dioxide. But respiration is that oxidation process where glucose is oxidized to release energy, and this energy is used to perform our day-to-day activities, and in this process carbon dioxide and water is also released. So these are the few changes or the chemical changes which we observe in our day-to-day life. In the above reactions, there is change in nature and the identity of the initial substance. What we have to note in all these reactions is that the initial substance is very much different from the final product. The nature and identity of the initial substance has completely changed, and such changes are what we call chemical changes. Okay, for example, let us look at this example now. Here, the ice undergoes the process of melting to form water, and water undergoes the process of vaporization to form steam. Here, there is only change in the physical state of the substance. Okay, ice is solid, water is liquid, and steam is gas. there is only change in the physical state, there is no change in the chemical composition or the chemical property of these substances, and such changes are called physical changes, and it is very much different from the chemical change. Okay, now let us look at the difference between physical change and chemical change. Okay, physical change, only physical properties of the initial substance changes. Note that the chemical properties remain unchanged. Only physical properties like melting point, boiling point, physical state, etc. change, but chemical properties remain unchanged. Chemical changes, the chemical composition and the chemical properties undergo change. Okay, and physical change, no new substances are formed in the reaction. Here the ice, water and steam have the same chemical formula, that is H2O. There is no new substance formed in this change. Okay, and therefore it is physical change. But whereas here iron is converted into iron oxide, so there is a new substance formed which is iron oxide, and therefore it is a chemical change. So this is a basic difference between physical change and the chemical change. Now a few activities are given in the book. Let us take a look at it one by one. Okay, so activity 1.1, take about 2 centimeter long magnesium ribbon. Okay, we have to take about 2 centimeter long magnesium ribbon. Clean it by rubbing its surface with sandpaper to remove magnesium oxide layer. This is an important step because the magnesium ribbon has a coating of magnesium oxide, and this magnesium oxide layer makes it less reactive. Okay, when we heat it, it does not react easily, and therefore we have to take the sandpaper and rub its surface to remove that magnesium oxide layer, and therefore the magnesium gets exposed, and when we heat it, it reacts. Okay, now hold magnesium ribbon with a pair of tongs, then burn it using a burner. So we have to burn it using this burner. Magnesium ribbon starts burning with a dazzling white flame. Okay, it burns with dazzling white flame, and it forms a white powder, and we have to collect this white powder in a watch glass, and this white powder is called the magnesium oxide powder. Okay, so this is the chemical reaction of this process. Magnesium plus oxygen gives magnesium oxide. Okay, to balance this equation, we have to learn the chemical equation, which will be uploaded in the next video. So this activity 1.2, take lead nitrate and potassium iodide solutions in different test tubes. So we have to take lead nitrate and potassium iodide solution separately in 2 test tubes. Note that these 2 solutions, when they are separate, they are colorless solutions. Okay, now we have to mix both the solutions. When we mix both the solutions, yellow colored solid precipitate appears. Okay, and this yellow colored solid precipitate is lead iodide. Okay, initially we had lead nitrate, and the final product which is formed is lead iodide. Okay, so this is the reaction of this process. Lead nitrate PbNO3 twice plus potassium iodide Ki gives lead iodide PbI2 plus KNO3 potassium nitrate. So we have to just exchange the anions to get the product. This is just a trick to remember this equation. Okay. Activity 1.3, take a few zinc granules in a conical flask. So we have to take few zinc granules in that conical flask and add dilute hydrochloric acid or dilute sulfuric acid to this conical flask. Note that these two are acids and they are dilute and not concentrated. Okay, when we add dilute hydrochloric acid or dilute sulfuric acid to zinc granules, then we see small bubbles that arise from the surface of zinc granules, and this gas is hydrogen gas. Okay, how do we know that this gas is hydrogen? So there is a test for this. We have to bring a burning candle near this gas, and this gas burns with a popping sound, and this is a characteristic of hydrogen, and by this we can confirm that the released gas is hydrogen gas. Okay, and heat is also released in this reaction, and hence it is an exothermic reaction. So here is the reaction of zinc granules with dilute sulfuric acid. Zinc plus dilute sulfuric acid gives zinc sulfate plus hydrogen gas is released, and heat is also released in this reaction. So this is activity 1.3. From the three activities which we performed previously, we can conclude some observations to determine whether the chemical reaction has taken place or not. So here are the four observations. Change in state, change in color. So in activity 1.2, we saw that lead nitrate and potassium iodide, initially they were colorless, and finally a yellow colored solid precipitate appeared. Evolution of gas. In activity 1.3, we saw that zinc granules, when it reacts with dilute sulfuric acid or hydrochloric acid, hydrogen gas is evolved. Okay, and change in temperature, exothermic reaction or endothermic reaction, there is change in temperature, and hence these are the observations which we can conclude from the activity. By this, we come to the end of the introduction part of this chapter. In the next lecture, we will look at the chemical equations. Until then, take care, work hard, all the best.